Hello scholars. So let's continue with answering the past question papers for the last examinations. Let's take the question number 1. Please, if you know you've not subscribed to this channel, please do so by pressing the subscribe button and also clicking on the notification button so that you'll be notified whenever we post a new video. Thank you. Now the question says, which of the following response or which of the responses contain all the statements that are consistent with the Bohr's theory of the atom? Now the first one you have here is, an electron can remain in a particular orbit as long as it continuously absorbs radiation of a definite frequency. Is that true? Can it remain in an orbit as long as it continuously absorbs radiation of a definite frequency? Now, number 2, we have the lowest energy orbit are those closest to the nucleus. That is true. The lowest energy are the one closest to the nucleus. I explained that in class today. Please, let's take note. If we have something like this, now this is a positive charge. Now these ones, they are the lowest energy orbit. They are the one closer to the nucleus. This one here closer to the nucleus as compared to these other ones that are higher energy orbits. Okay, so that is that. So that is correct. Now an electron can jump from K shell to M shell by emitting radiation. Now from K to M, is it increasing? Like, are you jumping from high to low or from low to high? From low to high uses absorption. When it absorbs radiation, it jumps from low to high. Why? From high to low is what? Emission of radiation. Emission of radiation. So the correct answer to this question, this is false. Now, an electron can remain in a particular orbit as long as it continuously absorbs radiation of a definite frequency. Is this true? Now, if you look at this, to an extent, this is true. So the correct answer to this question is what? This is not true. Because if it absorbs radiation, what will happen? It will jump to a higher energy level. So the correct answer is 2 only, which is option B. Now, the Heisenberg uncertainty principle states that no two electrons in an atom can have the same set of 4 quantum numbers. That is false. This is the Pauli's exclusion principle. The Pauli's exclusion principle. Now the next one is 2 atoms of the same element must have the same number of protons. This is wrong. It is impossible to determine accurately both the position and momentum of an electron simultaneously. This is right. Are you getting it? This is what the Heisenberg uncertainty principle states, and the correct answer is C. Now the next, which of the statements about the 4 quantum number describes electron in an atom? Let me tell you the question again. Which statements about the 4 quantum number which describe the electron in an atom is incorrect? Now you have the first one. The first one says n is equal to the principal quantum number, and n have values of 1, 2, 3. That is true. N is equal to the principal quantum number, and n has values of 1, 2, and 3. Now you have L is equal to the azimuthal quantum number. That is true. And L has values. No, L has values of 0, 1, 2, 3, down to n minus 1. So the correct answer to this question is option B, because you are looking for the one that is incorrect. Okay. Now ML is the magnetic quantum number, and ML has values ranging from minus L through 0 to plus L. That is correct. Now the spin quantum number MS is equals to plus half or minus half. This is correct. The magnetic quantum number is related to the orientation of atomic orbitals in space. All these are correct, but this is incorrect, and we are looking for the incorrect one. So the incorrect one, we make the right answer. Hence the correct answer to this question is option B, which is L is equal to the subsidiary quantum number, and the subsidiary quantum number has values of 0, That's values of 0, 1, 2, 3. Where 0 is for s orbital, 1 is for p orbital, 2 is for d orbital, and 3 is for f orbital. So the correct answer is option B. Now let's look at the next. Which atomic orbital is spherical in shape? Now, s orbitals are spherical in shape. P orbitals are dumbbell. D orbital are double dumbbell. And the f orbitals are complicated. That means their shape is complex. Okay? So the correct answer is 2s. Regardless of the energy level, all s orbitals are spherical in shape. Now, the maximum number of electrons that can be accommodated in a sublevel for which L is equals to 3 is, now the maximum number of electrons is given by the formula ml is equal to, let me give a formula now. Maximum number of electrons where L is given by ml is equals to 2 bracket 2L plus 1. Use this formula. Where L is given is 2 bracket 2L plus 1. So our ml now will be equals to 2 bracket 2 times, where the value of L is 3 plus 1. Now we have to solve everything inside the bracket. So this becomes 2 bracket 2 times 3 is 6 plus 1 is 7. And ml will be equals to 2 times 7 is 14. And this is equal to 14. So the correct answer is 14. Now the next. The ground state electronic configuration of arsenic is... Where's the ground state electronic configuration of arsenic? Arsenic has atomic number of 33. And therefore, it will have 33 electrons. Now, writing the electronic configuration, what will it be? It will be 1s2, 2s2, 2p6, 3s2, 3p6. How many have we counted now? This is 2, 10, 18. Then we have 4s2, 20, 3d10, 30. Then after 3d10, what are we supposed to have? We're supposed to have 4p6 or 4p. So we already have from here this way is already 30. So how many do we need to complete 33? 3. So we have to add that one to the p orbital, and that makes it 4p3. So this is the correct electronic configuration, and I believe the correct option here is E. So the correct answer is option E. That is the electronic configuration for arsenic, option E. And that makes option E the correct answer to this question. Let's take the next. Which of the following electronic configuration is correct for nickel? Now, nickel has atomic number of 28 in the periodic table. If you come here, look for nickel. This is nickel. It has atomic number of 28. Now, if nickel has atomic number of 28, it means that nickel will also have 28 electrons. And if it has 28 electrons, what will be the electronic configuration? To be 1s2, 2s2, 2p6, 3s2, 3p6. That is how many now? 2 plus 2, 4, 10, 12, 18. Then we have 4s2 and then 3d. Now, if you count this, these are many? 10, 3d, 8. This is the electronic configuration for nickel. Now, but if you should look very well, we can use the short notation, the shorthand notation, to actually represent the condensed electronic configuration. Now, the condensed electronic configuration is one in which you look at the nearest noble gas to nickel and then use that noble gas to predict the electronic configuration of nickel. So you now come here now. Which of the noble gases is the nearest to nickel? Let me look at the periodic table. This is where nickel is. The noble gas that is nearest to nickel is argon. So we have argon. Noble gas nearest to nickel is what? Argon. That means not from the right hand side, like the noble gas that precedes nickel, the one that comes before nickel is argon. After that, you have krypton in front, but the one that comes before is the one we take cognizance of, which is argon. So all what we do now is we now, how many electrons does argon have? Argon is 18 electron. You now come here and count 18. Which is how many? These are many? 2 plus 2, 4, 10, 12, 18. So from here down now means this is the electronic configuration of what? Argon. So you can now come here and say this is argon. So from here down is for argon, and then you now have 4s2 and 3d8. So your correct answer now is argon 4s2 3d8, and that makes option E the correct answer to that question. Now let's look at the next. The next question says the outer electronic configuration of Ns square Np4 corresponds to which of the elements? Now I told you that anytime you are given something like this, such a way that this N and this N are the same, what do you do to them? You add the power to get the number of electrons in the valence shell, and the number of electrons in the valence shell will give you the information about the group to which the elements belong. Is that not so? So you now have 2 plus 4, and 2 plus 4 is 6. So this one tells you that the element in question is a group 6 element. Now, which of the elements here are group 6 elements? If you look at the periodic table, the group 6 elements are oxygen, sulfur, selenium, tellurium, polonium, and what? Livanorium. But all these ones, they don't matter. Just oxygen, sulfur, selenium, and tellurium. So any one of these, if any one of these falls into the answer option, it means those ones are the what? Correct answer, because they are the group 6. Arsenic is wrong, calcium is wrong, chromium is wrong, bromine is wrong, and sulfur is the correct answer because sulfur is a group 6 element that has 16 atomic number. Now, let's go to the next. In the ground state of a copper atom, there are dash unpaired electrons and the atom is said to be dash. Now, cobalt rather has atomic mass, atomic number of 25. If you go to the periodic table, you agree with me that cobalt has atomic number of 27. Let me bring it out. This cobalt, you can see it has atomic number of what? 27. So you now come here and then write atomic number of 27, not 25. So if cobalt is 27, what would be the electronic configuration? It will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d7. Now, one thing that you must take note of is all these ones here that are fully filled are all paired. They are what? All paired. So all the fully filled orbitals are paired. But if you look at d orbital, it's not fully filled because the d orbital can take a maximum of how many electrons? 10. S orbital can take a maximum of how many? 2. P can take a maximum of how many? 6. D can take a maximum of 10. And F can take a maximum of 14. So the d orbital has vacant orbitals, and hence you should be able to draw it out. Now, d orbital has 5 suborbitals in it. So we draw the 5 suborbitals, which is 1, 2, 3, and then 4 and 5. So this becomes 1, 2, 3, 4, 5. Here is 6 and what? 7. This is the electronic configuration. According to Hund's rule, it states that you should fill singly before what? Pairing. If you discover what I did, I filled all singly, then I came back to pair. So in this case now, how many unpaired electrons does it have? It has 3 unpaired electrons. And I said that when an atom has 3 unpaired electrons, that atom, if it has unpaired electron rather, it's paramagnetic. Any atom that has unpaired electron is paramagnetic. So we can say that it has 3 unpaired electrons and it is what? Paramagnetic. So that's the answer to that question. Now let's look at the next. Which of the following set of quantum number could be those of the distinguishing last electron of molybdenum? Could be those of the last electrons of molybdenum. Now let us go to molybdenum and then predict the last electron. Molybdenum has atomic number of what? Let's go and look for it. Molybdenum is 42. This molybdenum here, okay? Let me use blue pen, think. This molybdenum here, 42. So it has 42 electrons. So you come here and say 42 electrons. Now, what will be the electronic configuration for 42 electrons? It will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. These are many now. This is 10, 20, 30. After 3d10 is 4p6. After 4p6, what are you supposed to have? 5s2. That is how many now? That is 38. Then after 5s2, what are you now supposed to have next? Then we now have 4d4. If you count everything here, it's supposed to be these 4, 10, this is 20, 30, 36, 38, 42. Now, but listen, this 4d orbital, it confers more stability when it is halfly filled or when it is fully filled. So this 4d4 is almost going to be what? Halfly filled. Are you getting it? Because the d orbital can take how many electrons? 10. Half of 10 is how many? 5. So whenever you are given anything like this, and you see you have 4d4, almost going to what? 5. One of the electron here will be promoted. That is when it is 4d4. One of the electron here will be promoted to make it to be what? Halfly filled. Because if one of the electron comes here now, it will not be 5. And 5 is half of 10. And this is more stable than when it is 4d4. Now, same thing is applicable if it is 5s1, 3d9. Now, what do you do in that case? You promote this one here. I mean, 4, let's say 5s2, 3d9. Now, when the d orbital is fully filled, it confers more stability. So what do? You promote one electron to this place. And then this becomes 5s1, 3d10. So when it is almost halfly filled, like 4, you promote one electron to make it 5, so that it will be halfly filled. When it is almost fully filled, like 9, you promote one electron, not 8, so it must be like 9. You promote one electron from the 5x to here to make it 10. So for all d orbital, it follows the same rule. So these become 5s1 and 4d5. Now, which of them is the valence electron? The valence electron in this case is 4d5. Now, the question is, which of the following set could be those of the distinguishing electron of molybdenum? Now, 4 is telling you that it has the principal quantum number equals to 4. So in that case, our n is equal to 4. Now, d orbital, what is the L value for d orbital? We say we have s, p, d, f. L value for s is 0, p orbital is 1, d orbital is 2, and f is 3. So d orbital is 2. So our d must be what? 2. So if n is 4, L should be what? 2 for d orbital. And then our ml can be -1, can be -2, it can be anything. Then our ms can be what? Plus half. Is that okay? So our ml value can have anything ranging from -2 through 0 to +2. While our ms can have value ranging from +half and what? -half. So what are we going to do now? This -2 now, you break it down until it gives you 0, which is -2. After minus, what do you have? -1, then 0, +1, and what? +2. So our ml can be any of these. In this case now, our n is 4, correct? L is 2, correct? ML is -1. We said ML can be any of these values here. So -1 is correct. And MS can either be +half or -half. So this is correct. And this makes this option the correct answer. Now, if you look at n is equals to 5, this is wrong. This is wrong. This is wrong. Now, this particular one is wrong. Why is it wrong? Because n is 4. L is what? 2. ML can never be 9 when L is 1. Is that okay? So the correct answer to that question is option C. Now let's look at the next. How many p electrons are there in an atom of rubidium. Now, what do you need to do? Go to the periodic table. Look for rubidium. Yes, rubidium. Rubidium is 37. So you come here and write the electronic configuration for rubidium. Now, what do you think will be the electronic configuration for rubidium? Rubidium has the following electronic configuration. You have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and then 5s1. This is the electronic configuration because rubidium is 37. Now, all the p electrons here are how many? We have 2p, so you come here and say 2p6, plus you have another one again, 3p6, plus you have another one again, 4p6. Now, all the electrons here are how many? 6 plus 6 plus 6, which equals to what? 18. So total number of electrons is 18. Now let's look at the next. A natural atom of an element has 2 electrons in its first energy level, 8 in the second energy, and 8 in the third energy. This information does not necessarily tell us. Now it has 2, 8, 8. Now, does it tell us the atomic number of the element? Yes, it tells us. Because the atomic number now is what? 2 plus 8 plus 8 is what? 18. Now, anything about the element's chemical property, does it tell us? Yes, it tells us that this element, they are what? The inert gases. Because the valence electron is what determines the chemical property of an element. Now, the total number of electrons in the s orbital, the total number of electrons in the p orbital, the number of neutrons in the nucleus of an... Now, it tells us the total number of what? Electrons in the s orbital. That is true. Because from here now, you can now know that, okay, this is 1s2, 2s2, 2p6, 3s2, 3p6. These are many. 2 plus this is 10. This 10 and this 18. So it tells us the total number of electrons in the s orbital, which is 2 plus 2 plus 2, 6. And the p orbital is what? 6 plus 6, which is equals to 12. So it gives us information about these two. Now, the number of neutrons in the nucleus of an atom of the element, does it? No, it does not tell us the number of neutrons. It does not tell us the number of neutrons. So the correct answer is option E. Now, which of the following determine the charge on the electron? The charge on the electron was determined by who? Robert A. Millikan. What would characterize electrons in the cathode ray? The ray traveling to the cathode, that is true. Rays acquires a positive electric charge. Rays are deflected to a positive electric place. Rays are moved by a paddled needle. Now, the correct answer is, what would characterize electrons in a cathode? The rays are deflected to a positive electric plate. That is true. The rays, they don't travel to the cathode. They emanate from the cathode. That means they come from the cathode. They don't acquire a positive electric charge. They are deflected to a positive electric plate. We've said that before. Okay? So the correct answer is option C. Which of the following should experience a greater nuclear charge? Now the question says, which of the following should experience a greater nuclear charge? Now, how do you calculate for nuclear charge? We said the Z effective, which is effective nuclear charge, is equal to Z minus S. Here Z is equal to the nuclear charge. Nuclear charge. And nuclear charge is the charge of the proton, the positive charge of the proton. And then S is the number of core electrons. Now, if you look at oxygen, 2p electron, electronic configuration for oxygen is what? Oxygen is 1s2, 2s2, 2p4. That's the electronic configuration for oxygen. 1s2, 2s2, and 2p4. Now, how about that for neon? That for neon is 1s2, 2s2, 2p6. That for nitrogen is 1s2, 2s2, 2p3. And that for carbon is 1s2, 2s2, 2p2. Is that understood? Now, have we gotten the electronic configuration of these elements? Which of them is the core electrons? Now, we said the Z effective, or the Z effective is Z minus X. The core electrons are those electrons apart from the valence electrons. Now, the valence electrons in this case is the electrons having the highest shell here, which is 2s and 2p, 2s and 2p, 2s and 2p, 2s and 2p, and the valence electrons here. So in each of the cases, for this particular one, the valence electron is 2 plus 4, which is what? 6. For this one, valence electron is 2 plus 6, which is what? 8. For this case, valence electron is 2 plus 3, which is what? 5. And the valence electron here is 2 plus 2, which is equals to 4. Now, what are the core electrons? The core electrons are all electrons aside from the valence electrons. Now, in this case, the core electron here is this 1s2, 1s2, and 1s2. So, what would be the effective nuclear charge? You can say Z effective is equals to Z minus S. Z minus S is the nuclear charge. I mean, Z is the nuclear charge. The nuclear charge is the charge of the electron. Now, oxygen has atomic number of 8. So, if it has atomic number of 8, it means that the number of proton is also 8. Neon has atomic number of 10. Number of proton is 10. Nitrogen has atomic number of 7. Number of proton is 7. Carbon has atomic number of 6. Number of proton is equals to 6. So, in this case, you have 8, 10, 7, and 6. So, Z effective is equal to the nuclear charge is the number of proton, which are these charges here. Now, let's calculate for the first one of oxygen. It will now be 8 minus, I told you that the core electrons are all the electrons inside. In this case, it's 2 electrons. So, 8 minus 2 is what? Plus 6. So, for oxygen, this is plus 2. Now, how about for neon? Total number of nuclear charge, which number of proton is 10. So, you come here and say 10 minus. The core electron also is also 2. So, this becomes plus 8. Now, Z effective would be equals to that of neon, 7 electrons, 7 nuclear charge, minus how many core electrons? 2, which is plus 5. And then that for carbon is 6 minus 2, which is plus 4. So, which one has the highest effective nuclear charge here? Is plus 8. So, the correct answer is Z effective of what? Neon. And that makes B the correct answer to that question. Now, let's look at the next. Predict the trend of atomic size across a period in the periodic table. Now, across a period, the atomic size decreases across a period from left to right. So, atomic radii increases? No. Atomic radii decreases from left to center? No. Atomic radii decreases from left to right across a row. So, the correct answer is B. It decreases, does not increase. Then down the group, it increases, but across the period, it decreases. Now, predict the atom with the largest first ionization energy in the row. Now, ionization energy does what? Does it increase or it decreases? Now, the ionization energy increases across a period. So, the one that will have the highest ionization energy is the one that is far right of the row, because we said it increases. So, if that of sodium is 1, magnesium will be like 2, sulfur will be like 3, and this one will be like 4. So, it is increased. These are just assumptions, okay? So, the correct answer here would be what? Chlorine. Chlorine will be the correct answer. And this one will have the largest first ionization energy. And the next question is, what are the possible values of the quantum number m1 of an orbital in the second shell? Now, the second shell, n is equal to 2. Now, when n is equal to 2, what can be L value? L value is n minus 1. L is equal to n minus 1. So, L now will be n is 2, so 2 minus 1. And L will be equal to 2 minus 1 is 1. So, our ml value usually ranges from L through 0 to plus L. So, the correct answer to that question now is ml is equal to, we have minus 1, then you have 0, Then you have plus 1. So the correct answer to that question is supposed to be minus 1, 0, and plus 1. And that makes option. Now, it's supposed to be ml values and not L. But since you already have and not ms, but since you have ms already added here, you can choose option D as the correct answer. But that is not, because they didn't ask for the ms value. But this one now is the only one that that has the correct ml value of minus 1, plus 1, and 0. So that will be that for this episode. Thank you for your time. And make sure you subscribe to this channel. Turn on the notification button so that you'll be notified whenever I post a new video.